Okay, guys, in this video, we are going to introduce the dot product of two vectors, and then we are going to talk about some of its properties. Okay, so the first thing we're going to do is we're going to take vectors r and p. So first vector r, and it has components -3, 4, -4. And then we also have vector p, which has components 5, -5, 3. So to find the dot product, what we will need to do, and by the way, something that you need to remember is the dot product, first of all, looks like just like regular multiplication. So it doesn't look like there's any different, but it is a product of two vectors. Second, that it is a number. So dot product is not a vector. This is actually a common mistake. Dot product will be a number. Now, it could be positive, it could be negative, it could be zero, but it is going to be a number. So to compute it, we're going to take the x component of the first vector multiplied by the second. Then we're going to take the y component and multiply by the corresponding y component in the second vector. And then we'll do the same thing for the z components. And then you just add up the results. So this is going to be -3 times 5 plus 4 times -5 plus -4 times 3. Okay, so this is going to be -15, -20, -12. All right, so looks like that's -35 minus 12, so -47. Okay, now we'll come back to that part A, but I also want to talk to you about some of the properties of the dot product. So one thing that you can immediately notice is that it doesn't matter if you compute P dot R or R dot P, because you're just switching these around, but the multiplication is commutative, right? So that's going to be the same. So order doesn't matter here, which is not going to be the same for the cross product, which we're going to take a look at in the next lesson. Also, what happens if you dot a vector with itself? So imagine that I take vector p and I dot it with itself. What's going to happen? So vector p is 5, -5, 3, and I multiply it by itself, 5, -5, 3. What will happen? So again, we're going to just take 5 multiplied by 5 plus -5 multiplied by -5 plus 3 multiplied by 3. But we can also write this as 5 squared plus -5 squared plus 3 squared. And that should remind you of something, right? Do you remember how you found the magnitude of a vector? You would just square each component and add them up. But at the end, you would have to take the square root. So here you do not take the square root. So the property of the dot product is if you dot a vector with itself, you're going to get a magnitude of it, but it's going to be squared. So this is magnitude squared, okay? So that's how we get this part. So this is going to be 25. Remember, when we square a negative, that goes away. So 50 plus 9 is 59. So that goes here. Let me just check to make sure this is right. Okay. Now, the last one we have to do is actually come back to part A. And we already found the expression in parentheses, right? We already know that that's -47. And then this is just a number, okay? And we want to multiply that by vector q, so that's -1, 0, 2. So to do that, you are basically distributing that -47 to each part. So I think I will have 47, right, positive, then 0. Then 2 times 47, I think that would be 94 if I'm negative. Now it's correct.